this is part 3 of, what are we at? We're in section 5.2, definite integrals. This is part 3. Last two example 4 and example 5. Example 4 reads, if it is known that the integral from 0 to 10 of a function f of x dx is equal to 17, and it is known that the integral from 0 to 8 of that same function is equal to 12, what will be the integral from 8 to 10 of that function f of x dx? Okay. So what you'll notice here is the integrand in each of our integrals is the same. The only thing it is changing is our limits of integration. So essentially what they're saying is, for some function out there, y equals f of x, from 0 to 10, all of this bounded region right here, all of that is in blue adds up to 17. And that if we were to stop at 8, then this piece is 12. So how much then is this piece right here going to be? So what will be that remaining piece? Now, if we make a geometric argument like this, we can say, well, if this much of it is 12, and the blue piece is 17, then the difference between those, I think I had it in red, right? This down here must be 5. But what we're really making, the argument we're really making here is we're making use of this argument. The integral from a to b of f of x dx is equal to the integral from a to c of that same function f of x dx plus the integral from c to b of the function f of x dx. Except we are saying that this is 0, this is 10, this is 0. This is 8, this is 8, this is 10. So then we have 17 is equal to 12 plus, I don't know. We'll call that just plain old x because we love x's for variables for unknowns in algebra. And then we can solve and say that that's 5, or to wrap it up and make it look pretty and answer the question, the integral from 8 to 10 of f of x dx is equal to 5. Okay. So basically what they've set up here for us is they've set up an algebraic equation with 3 pieces, 1 piece, 2 piece, 3 pieces, an equal sign connecting them. So if you know any 2, you should be able to find the third. For example, if you were told that this was 9 and this was 6, what would that one on the end have to be? Oh, that would have to be a -3 to make it work, right? And we're relying on the property that says an integral from a to b is equal to an integral from a to c plus that same integral from c to b. Right? You'll see that these 2 limits of integration are over there, and that these 2 guys have to match. Okay. All right, our last example then, example number 5. The graph of G consists of 2 straight lines and a semicircle. Use it to evaluate each of the following integrals. Okay. So the first one asks us to find the integral from 0 to 2 of g of x. Well, this whole thing is the graph of g of x. The integral from 0 to 2 says find the area starting at 0, stopping at 2, bounded by that curve. Well, excuse my poor drawing, but isn't that a triangle? That's a triangle that has a base of 2 and a height of 4. So what will be the area of a triangle with a base of 2 and a height of 4? Well, Area of a triangle is 1/2 base times height, so 1/2 times 2 times 4 gives me 4. So the value of that integral is 4. Right. The second piece asks me, what is the value of the integral from 2 to 6? Well, there's 2, 3, 4, 5, 6. So there's 6. So they want this piece now. Now what I learned a little while ago was the blue piece, because it is above the x-axis, we interpret as positive area, but this orange piece is going to be below the x-axis, so we're going to interpret this as negative area. So that means that I need to find the area of this and then make it negative. Now I'm told that this is a semicircle, so it will have a radius of 2. And so the area of a semicircle, well, the area of a circle is pi r squared. So the semicircle is just half of that. So 1/2 times pi times the radius 2 squared. I believe that's just 2 pi. So then what's going to be the value of this integral? Negative 2 pi. And again, remember, why is it negative? It's negative because it is below the x-axis. Below the x-axis, negative area. Above the x-axis, positive area. All right, so then moving on to the last example. They're asking us then to find the integral from 0 to 7. So 0 to 7 says the blue plus the orange plus that little tiny green on the end. And I believe that little tiny green on the end is a triangle with a base of 1 and a height of 1, so that would have a positive area of 1/2. So I think the integral from 0 to 7 would be the positive 4 from the blue plus the negative 2 pi from the orange plus the positive 1/2 from the green for a grand total of 9/2 minus 2 pi. So we have finished section 5.2. You can now complete all the homework for section 5.2. In the next video, we'll start with section 5.3. I'll see you back here for that one.